We're going to start by talking about these just-in-time supports around vocabulary building. We have here a vocabulary building support found on a wall in an SPS classroom. We're going to talk about some features of vocabulary supports that lend them to serving as a just-in-time support. This image is from the middle school CEA guides with that geometry reference chart kind of added in as a primary thing found in the high school guide that is not found in the middle school CEA data analysis guide. This section in yellow here is ideas for just-in-time interventions that are based around the results that we see for our students' work in the CEAs. We're going to start by talking about some of the features of vocabulary building that lend it to serving as a just-in-time support. And then we will go through and look at an example of how we might do this on the basis of some hypothetical CEA results. We're going to start with this quote from Academic Vocabulary in Middle and High School, Effective Practices Across Disciplines. It says, words are only one way in which these concepts can be presented, so it's important to think of vocabulary knowledge in math and science disciplines as being more than word knowledge, but rather knowledge of meanings. We want students to know the meaning of the word trapezoid, but we also want them to recognize when a plane figure is a trapezoid, how it differs from other plane figures, and how it can be used in mathematical reasoning. Complex concepts are part of the general complexity in math and science, so teaching meanings can take time and repetition. Notice here that we want students to recognize examples, identify non-examples, and use the associated concept in math reasoning as part of the vocabulary. That's why focusing on math vocabulary can be an effective just-in-time intervention. It's really tied closely in with our concepts. To make sure this connection is kept together, we want to make sure that we are connecting this vocabulary and content. When you teach math vocabulary in context, use examples and non-examples, include diagrams, and have students co-create a student-friendly definition and durable reference, then vocabulary instruction naturally reinforces math concepts. Teaching in context can include relevant problems, relevant classroom discussion, and real-world applications. That connection of the vocabulary to examples and non-examples, and also diagrams or other visuals of the characteristics of a thing that fits into that definition. And co-created durable reference could be an anchor chart, a word wall posting, such as that living word wall that we started looking at, where things keep getting added on, or a notebook or a journal page that students keep. And those can also be co-created when we talk about them together as a class, do some of the work on what that journal or notebook page might look like together on a whiteboard so that we all end up with accurate references. One of the ways to do this is with Frayer models. They might be part of students' math notebooks or journals, or they might be made with 11 by 17 or chart paper and posted on the wall. Some important features of the Frayer model is it's got a definition, and it should be a student-friendly definition so that they own and understand what is being said there. Include those key characteristics. And again, examples and non-examples, which may often be visual. Here are some examples of Frayer models for the idea of linear functions that students might have in a math notebook, or that could be done larger on a classroom wall. Envision has some a variety of other graphic organizers in addition to Frayer models. The start of their topics have some amount of language development. It might be a little bit of fill in the blank and other work on it, but many of the topics also have a graphic organizer like a Venn diagram, or the one that we see on the top right, which has the vocabulary term, a definition, and kind of cut off on the end, space for an example. And there's a number of these on the page. They can be found in the teacher guide and also in the student workbooks for the start of each topic. Another curriculum embedded resource is the geometry reference chart. And this image is from the completed reference chart for all units for teachers from the geometry resources in IL Classroom. There's a blank version for students, which could be used for co-creation on the whiteboard prior to having students complete their own. There's also a scaffolded version that has the type, a fill-in-the-blank statement, and the image pre-filled. A caution about the scaffolded version is that it removes a lot of the potential for students co-creating in that initial completion, since so much is pre-filled in. In order to really help it stick and have students have ownership, it might be a good idea to have students rephrase the statement and create another example as a whole class or in partners, and then share out as a whole class after they complete the scaffolded version. Either way, it will be more effective if students are explicitly referred back to the reference guide and directed to use the terms out loud and in writing with some frequency. Just any time that we are learning vocabulary, it's really helpful to say the words out loud. If you've ever studied a foreign language, probably found that just rehearsing a word in your head is maybe less effective than saying the word out loud. So moving forward with wall displays beyond just Frayer models that we might put up, vocabulary can be connected directly to visual definitions on something like an anchor chart that might be co-created with students to include vocabulary in context during the concept development and posted to a wall, like the parts of a coordinate plane poster shown in the second block there. And these displays can be created or reviewed as a just-in-time intervention. The really important features of a wall display are that they are large and easy to read everywhere in the classroom so that students can refer to them on their own, regardless of where they're seated, that they include the meaning and or a visual example. Perhaps the visual example gets at the meaning, like that x-intercept in the top image. Both of those images are found on SPS Classroom walls. And the third thing is, as I was saying about that geometry reference guide, that you explicitly refer to this reference, in this case, a wall display, often to reinforce the content and the associated vocabulary through the content. There are some important additional considerations that we want to talk about. And the first is connecting to words in other languages, especially cognates. We want to celebrate linguistic and cultural diversity in our classrooms. We can do this by explicitly including words from students' home languages. Cognates can be particularly helpful, words that are very similar in other languages, which happens frequently in Spanish. And we want to be careful not to ignore students whose home language is not Spanish. There are math glossaries available for many of the first languages common to SPS students, including Spanish, Vietnamese, and Arabic from our NYU bilingual glossaries and cognates that we'll look at in just a second. I was also able to find a resource for Somali, but I haven't yet identified a resource for Amharic to round out our top 5 languages in SPS. You can ask students how to say the word or phrase correctly and have all students practice saying the word in English and another language together before a partner share about the meaning to support all students in concepts and development, and to support having an inclusive classroom. And you can add additional vocabulary or languages to an existing wall display as part of a just-in-time intervention, providing kind of a way to refer back to it and review. I have already pulled up that link here, and this is where it will land. It will be in our follow-up video. We have bilingual glossaries and cognates, and we can kind of scroll below ELA. There's math glossaries at all levels. Some words might be found in middle school math and not repeated in the high school algebra. So when I was looking for the word domain that we'll look at later, it's not present in the algebra dictionary, but it is in the middle school math dictionary, just as a caveat. So if we click on, I'm just gonna pick on the Spanish middle school math, it's gonna have things here alphabetical for grades 6 to 8. But in some of the high school ones, things are by topic. So we'll look at here. It's going to have problem solving, reasoning, and proof. So it might take a little bit of looking through to find the things you want, but it's got math specific meanings that we have lots of smart folks over at NYU who are making sure that these are good translations. There's also, and you see we have all the high school classes, even some calculus, and there's some Common Core math terms addenda here, and some supplementary math glossary. There's quite a few languages that can be found here. And then you can find your math terms to share. Let's see if we can pull up. It really wants to, sorry about that. We also want to really pay careful attention to words that have multiple meanings, especially that might be used in casual conversation or other subjects. We'll talk more about that on the next slide. And have students repeat the word out loud when you introduce it, and introduce new words in a sentence stem, or include new words in a sentence stem for partner talk so that they get more chances to practice saying it right up front. Have students write the new word in notes or to complete a sentence frame so that we're really getting those new words frequently, both orally and in writing. That really helps with vocabulary development and really tying that vocabulary to our math concepts. Going back to that attending to multiple meanings, some math terms have common meanings as well as domain-specific meanings. Words like balance, which has a common meaning in the sense of balancing on a balance beam or on one foot. It also has a meaning in physics, balancing forces, or in chemistry, where we are balancing equations similarly, but not in quite exactly the same way as in math. We also have words like opposite, maximum, minimum, domain that we'll talk about in our example in a little bit, and range. It can be really helpful to compare the discipline-specific meanings to the common meanings, and to start this off by reviewing the common meanings so that we're kind of all on the same page with how we extend to the discipline-specific meaning for our words. That was a super quick overview of vocabulary building as a just-in-time intervention. Let's take a moment to choose a question here to answer in the chat. We have four possibilities. What role do examples and non-examples play in helping students understand and apply math vocab and concepts? How can having students say and summarize the meaning of math vocab increase student retention of math vocab and concepts displayed? Why might having students co-create wall displays deepen the learning of both vocabulary and math concepts? Or lastly, think of a time when you learned a new word in context rather than in isolation. How did the context help you understand and retain the word more effectively? And just take a minute to answer one, put it in the chat. I like that, creating equals doing. Students need to try out the new language multiple times before they remember and understand it. I think non-examples play a role because it allows kids to preview what mistakes not to make. Examples, non-examples can be used to highlight misconceptions or other properties that are often overlooked in words alone. Examples and non-examples. Oh, it's scrolling past me. Thank you all for putting so much in. Help solidify multiple representations and visualizations of new words and concepts. And context gave me visual and practical applications for the term. Co-creating means the display is theirs instead of belonging to the teacher. That I relearned the word ennui in context when I was watching Inside Out 2. A few days later, I read it in a book and recognized the word and weird spelling right away. Yeah, so we have lots of great sharings. Keep them coming. In the interests of time, going to move to the next slide as soon as I find where I'm at over here. All right, so we're going to move into our example here. I appreciate everyone sharing in the chat and hope that you keep those coming if you have more things to add. Let's suppose that I have a significant number of students who struggled with questions 1 and 6 on the second CEA for Algebra 1. That would be Unit 4. Problem 1 is a multiple choice question about domain and range. And question 6, part B, asks students to describe the domain of a function as completely as possible in a free response. Both of these are looking at the standard HSF-IF.B.5. And if I go into my CEA data analysis document, it's telling me that in Unit 4, students did all this work with functions, and they'll have future opportunities to revisit the standards from Unit 4 in all of the subsequent units. This is in the data analysis forward planning section. Continuing to scroll down a little bit, I might notice that this standard that 1 and 6 both address says relate the domain of a function to its graph and where applicable to the quantitative relationship it describes. And that we have future opportunities in lots and lots of lessons, but one that might be upcoming is Unit 5, Lesson 19, which one changes faster. If I go in my platform to that lesson, Unit 5, Lesson 19, I noticed that domain and range appear in the warm-up synthesis, but now it's talking about the domain and range for the window. It's kind of extending this meaning beyond that of a function. And in addition to wanting to revisit this content, perhaps this will be confusing to some of my students. I also don't want to break up the warm-up while I think about adding some vocabulary building here. I don't want to split it up between the warm-up and its synthesis or add too much time to the lesson. I might decide to address domain starting before the warm-up by addressing some common meanings and the mathematical meaning that we learned earlier in Unit 4 or reviewed in Unit 4. And then when I get to the warm-up synthesis, I can just extend that meaning of domain to make sense of this prompt. Here's what that might look like. As students come into the class, they might see this prompt. When do you use the word domain in everyday life? What does it mean in that context? And in what other subjects at school have you used the word domain? Take just a minute to think about that and pop an answer into the chat. No, it's after school on a Monday. Hopefully you've at least eminent domain in government. Yeah. The queen in her domain. Oh, my home is my domain. I love it. The queen in all her domain. Yeah. Domain is your area. Yeah. Realm. Yeah. For our students, they might have more familiarity with some more common terms. Thank you for sharing where they came up with. I made a cute little montage video of some uses for domain that I might show to my students after they share where they have heard or used the term domain in everyday life. Promise it's less than 1 minute. Real quick watch here.
Internet. Today I'm going to be explaining what is a domain name. So in the simplest terms, a domain name is just the address to your website.
And today I want to discuss the domain mechanic. This is a mechanic that is returning actually.
Today's tutorial will focus on understanding and managing your domains, or the land you own within your own realm.
Eminent domain is the term used to describe the government's power to seize private property for public use.
It's a concept framers of the Constitution deemed so important, it's in the fine print. The idea that all artwork at some point becomes public property. Lee Cowan delves into the universe of public domain.
All living things found on Earth can be divided into 3 large domains based on their characteristics. The 3 domains are bacteria, archaea, and eukarya.
Hopefully you could all hear that. All of my tech blew up over the break, so I haven't got it set up so I can see the chat while I'm presenting it. Once we've kind of collected some ideas and understanding of how we have heard or used domain in everyday life or in other subjects, then we want to move to thinking about our math term domain. I might ask students, what does domain mean in math? How does the math meaning connect to common meanings? What are some words in other languages for the math meaning of domain? And I could record these answers on a Frayer model, perhaps on chart paper, or if there's already a durable reference for domain up on the classroom wall, even if it's an anchor chart that was hidden behind a few others, I could pull it back out and add some connections to the common meanings to that reference. Can co-create a student-friendly definition for our math meaning of domain. And we could include or add home languages for as many students in our classroom as possible that connect to the mathematical meaning of domain. Here, I have included a possible student-friendly definition, the possible X values for a function or situation, a potential connection to common meanings. Perhaps the domain is what you control, kind of, the independent variable or inputs, or what the government takes from you in that eminent domain case. Some other characteristics like the furthest left to the furthest right, X values on a function that's a line or part of a line, curve. I have some common home languages for SPS students. I have the Spanish dominio, which interestingly enough is the same spelling at least as in Portuguese. I have from my NYU bilingual glossary, the Arabic term for domain, and some Vietnamese under the definition that is courtesy of our own bilingual math teacher, Hein Tang, who was generous enough to provide and discuss translation with me. And this literally means the domain of a function is the set of values of the variables that make the function meaningful. So I put it over on the definition side. It's also a little big to put in under domain. And the Tagalog is also spelled domain, just as it is in English. So once moving forward, kind of foreshadowing, I left some space under the examples because of the constraints of PowerPoint. But if you have it on chart paper, you can always kind of paste some more chart paper on the bottom to extend it. And it was a little trickier to have some non-examples of domain, but I put in our common misconception where students confuse the domain with the range, which would be the possible outputs of a function, or the y values, lowest to highest of a function. Then we can get to our warm-up, and just for context, so we're not a little bit lost, here is the first slide of the warm-up. It gives them this little piece of a graph, asks them which equation they think the graph represents, and what information might help them to decide more easily whether the graph is that linear or that exponential model. And then there is the first part of the synthesis before we get to what we looked at in the beginning that asks students how they decided which equation was correct and what additional information could be useful. Could talk about this, and then moving to the last part of the warm-up synthesis, where it's asking us here, how does this larger domain and range for the window help you decide if the relationship is linear or exponential? And it kind of shows us in the little dashed in the very bottom corner what the original window was, and then this much larger window where we can see that this is not a linear model. From here, we can now add on to that reference that we either already had on the wall and reviewed briefly before the start of the warm-up lesson, or that we built at the start of class for the math definition after connecting to some common meanings. Things that I might add on then would be that the domain of a Desmos or graphing calculator window is the X values that are visible, and that a domain value is an input or X value. Just further extending this understanding of using domain in math contexts. And then I have that the domain of the window is that they showed in the original one was the numbers from 0 to 7.5. One of the things to consider for time for all of these graphs is, while it is more ideal to co-create, having them printed out and cut out so you can kind of pop the examples up could save some time, since we are extending our warm-up in order to do this review of unfinished learning and through our vocabulary building. Or if you're just not super good at freehanding graphs on large chart paper, like me, then you might want to have those kind of already printed and cut out, ready to tape on your examples for your anchor chart for the class. I also added to my non-examples that the vertical height of a window would not be the domain of the window. And the domain of the window would be a non-example for the domain of the function, which can be a little bit tricky and might bear some discussion in class. It's just one way that you could use our CEA data analysis tool and vocabulary building as a just-in-time intervention to support students with standards they might have struggled with on a CEA or other assessment. So we have the data analysis for the CEAs. With that, we have just a recap of the resources I talked about. There's the Envision Language Support Handbook and the language development pages at the start of each topic. There's the IM Geometry reference chart. There's also a reference list for SBA math vocabulary. They're both linked here, will be in the follow-up video. There are Spanish-English glossary. There is a Spanish-English glossary in the Envision student workbooks. And there is a Spanish language version of IM Algebra 1 that could also be a resource, as well as those NYU bilingual glossaries and that video on domain common meanings if that is something that you would want to review in an upcoming lesson. What are some ways that you use vocabulary in your practice currently? And or what new vocabulary practice do you plan to use on the basis of this? Take just a couple minutes to put that into the chat. Stephanie, I specifically did not use any Seinfeld clips in that domain video. So come back to the chat. Bilingual glossary is awesome. Hope to use that more. Anchor charts. Hadn't thought of having my ML students adding to the anchor chart. Yeah, it's really bring up that inclusivity and engagement for our ML students. Word walls. Paying attention to the language objectives for the lessons. Yeah, Envision has language objectives pulled out and explicit. I do the common meaning generation of the terms point, line, and plane, word walls, and anchor charts. Yeah. Plan to use the Frayer model to review vocab in the current exponential unit. That's that, unit 5. Regularly embed vocab into lessons and formative assessments. We ask students to write down words, visualize them, and represent them, as well as explaining to a partner their understanding of them. That's fantastic. They are saying it, they're writing it, they're using it in context. Anchor charts created by students are also used regularly. Excellent. Similar is a great word with many meanings. Yeah. The SVA math vocab resource. Yeah, that can be a great resource to really think about critical math terminology for students to know. Go ahead and keep putting things in. Just the last thing that I want to plug before I turn this over to our next topic is the Math Language Routines Read Wednesdays. We'll actually be talking about 3 reads in a couple of days, but these also provide another way of getting at vocabulary building, but also concept building and those inclusive classrooms for our MLs, as well as that language, that discipline-specific and academic language development that all of our students need.